Okay, so yesterday I went through if you have two bases and one exponent that you can convert it to a log. And then the day before I said, if you have two bases and two exponents, you make common base. Today we're going over solving exponentials with at least two bases and two exponents not by common base. All right. So our first example is going to say solve 5 to the 3x equals 3 to the 2x minus 1. Now, they often ask for exact values. Why would they ask for exact values? Because if they don't ask for exact values, your calculator is your best friend. Okay? So, how can we get it down to exact values? So, we have two bases, two exponents. That's why I said to you, in this instance, you always check if you can do common base, because if you can, it's way faster. But we can't common base. There's nothing to 3 and 5. We agree? Okay. So step 1, log base 10, both sides. Because what you do to one side, you do to the other, equations are happy. If you do something randomly to one side, adding it on by multiplication, and you don't do it to the other side, you've completely changed the equation. So we're going to go log, and the reason why I say base 10 is I used to not say base 10, and then you guys would try and drop the base of the exponent into the base. So you'd go log 5 to the 3x, base 5, which it's not. So I always hazard you to go log base 10, because if a log doesn't have a base, it is base 10. So I'm just going to put a 10 in there so that you don't try and put the 5 in that spot, because that's what happens all the time. So log base 10, 5 to the 3x equals log base 10, 3 to the 2x minus 1. Do you see how if you don't put the base 10, some people will try and put those bases of the exponent in that spot, which is not good. Okay, if I gave you a question like this, just at this step, if I gave you this question, what could you possibly think of to do next? Operation-wise. What could you think to do? Put the exponents in front of the log. That's step 2. Because you have to bring the exponents down, because where they are up here, it's impossible to do. So the reason why you log both sides is because our issue always is that these are stuck in the exponents, correct? If I log both sides using log laws, I can take my exponent and I can drop it in front and it's no longer an issue. So step 2 is power rule. If you're like, what is power rule? Right? Take exponents, drop in front. Okay? So you get 3x. I always put it in brackets because I'm going to have to remember to distribute it. Now 3x distributed is still 3x, so it's not a big deal. But the 2x minus 1 is going to have to be distributed. So I'm going to get log base 10 of 5 equals 2x minus 1 log base 10 of 3. Yeah. Is the 10 just a what? Yes. So when you log both sides, you are just logging it. And if there is no base, the base is assumed to be 10. Just like when you do a square root sign, if you don't put a little number in there, you assume it to be 2. That's how logs are. Okay? Now, what should we do next? Distribute so we are going to get 3x log base 10 of 5 equals 2x log base 10 of 3 minus 1 log base 10 of 3. You just distribute the 2x and the 1 in. 2x times this is that. Negative 1 times this is that. Just distributing the bracket in. Close. What could you do? What's ultimately in the end when I say solve? What ultimately do I want? I need x equals something, right? Something, something. Okay? So what I can do is, if you haven't noticed, the 3 times the x times the log 5 could actually be written like this. X times 3 times log 5. Could it not? Because multiplication you can do what with? Move it in any order you want. Okay? So what I'm going to do is I move the x's to one side. Anything with an x, any term with an x to one side. So I'm going to go 3x log base 10 of 5. Then I'm going to move this. How do I move a 2x log base 10 of 3? Minus it, yeah. Because it's a plus right now. And then we're just left with negative 1 log base 10 of 3. Why would I possibly want to bring all the x's to one side? Because you're collecting terms that are like, sure. But what do they both have in common? An x and a multiplication of x, correct? If I gave you this, what could you tell me you would do with it? 2xy plus 3xz. What could you tell me you would do? Take an x out. You could GCF an x out, couldn't you? And you'd be left with 2y plus 3z. Do we agree? So these are all just multiplied, are they not? Same thing here. I have 3 times x times log 10, 5, 2 times x times log 10. What can I take out of both of them? An x. What's left behind? Everything else. So I'm going to get x bracket 3 log base 10 of 5 minus 2 log base 10 of 3 equals negative 1 log base 10 of 3. Do we agree to that statement? It's really not that bad, but people choose not to learn it. So people leave blank, and I don't find it that awful of a thing, but it's the most common left blank questions on my test. So now what can we do? Nope, we need exact values. We want to get x by itself. What is it being, what is that log beside it? What's happening? You can just divide it over. So now we have this. On the top, there's nothing I can do. It's just going to stay that. Negative log 10, 3. On the bottom, what could I do? They're both base 10 with a subtraction sign in between. So you could use quotient law. But in order to use quotient law to put them together, what do they have to have in front of them? A 1. So I'm going to go bring the 3 up here, bring the 2 up here. So what am I actually going to get under here? I'm going to get log base 10. 5 cubed is 125. And it has a plus 1 in front of it now. So it goes in the numerator. Bless you. 3 squared is 9 and has a minus 1, so it goes in the bottom. Now you're extremely close to being done. Please, everyone, go to your formula sheet now. That step, quotient rule. You could either do quotient or product. You're literally just simplifying, you're simplifying the numerator and simplifying the denominator. You're kind of using power law, but I'm just going to. Okay, look at your formula sheet. On your formula sheet, at the very bottom of your log laws, it has this. It has log BC, log base B of C equals log AC over log base AB, doesn't it? So which side of this equation do we have right now? We have the right side. Both of our A's are what? 10. Does the A appear when I simplify it into this form? No. So you're going to end up with just negative. Oh, this negative has to come up here. Because you can't put this together unless they have plus ones in front, right? So this would be log. And what's 3 to the negative 1? 1 over 3. So that's going to go beside. And this is going to move to the base. And then you're done. That's if I want exact values. If I didn't want exact values, you literally could have y1, y2 this. If I wanted to the nearest 10th and I was asked algebraically, way back here, you could have just typed it into your calculator, right? Now, why does number 8 work? I'm going to show you why. So why the heck does number 8 even work? Why do those A's evaporate? Well, this is why. So they just kind of fade into abyss. But why do they fade into the abyss? Because you trust me? No, don't just trust someone. Ask them to explain why. So why does this work? I'm writing them side by side because both of these actually end up being fractions. What is log base A of C? How else could I rewrite that? Log C divided by log A. And how could I write this one? Log B divided by log A. And then you'd get log C over log A times log A over log B. And so you get log C over log B. And whenever you have it written like this, everyone remembers they can take this and write it. They can take this black log AC and rewrite it as this. But they forget that this can be just rewritten as the B being a base, right? Everyone forgets they can go from here to here. They remember to go from here to here, though. Same thing if they forget to multiply and expand to plus, but they can remember to simplify very easily. Okay, I'm going to give you one to try on your own, and then there's one that's a little bit harder but has just one extra step. So it's not actually harder. It literally is one extra step. I'll even do it out of your textbook because it'll be part of your homework. I don't understand what happened in the lab when you printed it like that. So if these bases are the same from your formula sheet, these bases can go away. And then what's on top stays on the beside the log. And I had 3 to the negative 1. I have to make it be up there, which is a third. I can't put them together unless the logs both are positive. Yeah. Okay. Try this one, please. So we get log base 10, 2, x minus 2 equals log base 10, 3, x plus 1. Drop in front, x minus 2, make sure it's in brackets so you remember to distribute it. Base 10 of 2 equals x plus 1 log base 10 of 3. Next step is to distribute. X log base 10 of 2 minus 2 log base 10 of 2 equals x log base 10 of 3 plus 1 log base 10 of 3. The next step, let's get the x's all to one side. I'm going to move it to the left. So I'm going to subtract it over. X log 10 of 2 minus x log 10 of 3. So I'm moving this to this side, but then I have to move this to this side because it doesn't have an x. So I'm going to get equals 1 log 10 of 3 plus 2 log 10 of 2. Then I'm going to take an x out. Log 10, 2 minus log 10, 3 equals log 10, 3 plus 2 log 10, 2. Divide it over. Okay, now the next step is to combine the numerator all together, combine the denominator all together by quotient or product rule. You have to use power rule a bit too, because this one has a 2 in front, and I can't put anything together by quotient rule or product rule if they don't have ones or negative ones in front. So I have to bring the 2 up here. Now I can put the top together. I'm going to get log base 10. This one has a positive 1 in front, so 3 stays in the numerator. This has a positive 1 in front now, so 4, which is 2 squared, stays in the numerator. Over log base 10, 2 goes in the numerator because I have a positive 1 in front. 3 goes in the denominator because I have a negative 1 in front. And then I told you we could omit the 10s because of the formula on your formula sheet and because of what I showed you it can do. The 10s will actually cancel when you when you multiply. So we're going to get log 12, and then this 2/3 becomes my base. And I should be able to y1, y2 and get the exact same decimal as that. Okay, last thing. Say I trumpet up 1. Where did I put my paper? Okay. So this is the hardest one that they can give you. And it literally has one extra step, 1. But you can star this one because everyone forgets about it. First off, they forget about that one. They really forget about this one. So solve 2 times 3 to the x equals 6 to the x plus 1. So whenever I've given you 2 numbers and an exponent until now, I've either made it so that you can divide the number over, or I've made it so you can do common base, where which of this you cannot do either. I get a ton of people doing this. Divide by 2, divide by 2. I have 3, common base. It's so easy, and can't give you any marks because you messed up. Or they go 2 times 3 is 6 to the x. Boom, common base again. I can solve it. Neither of those are proper actual mathematical things you can do. You cannot divide the 2 over because this 6 has an exponent. We agree? You also can't multiply because the 3 has an exponent. The only way you can combine exponents is if you have common bases. And 2, 3, and 6, none of those are common. Okay? So what do I do first? Log both sides. Exact same thing as I did before. Log base 10 of 2 times 3 to the x. And I specifically write it like this so I spot that, hey, there's a multiplication sign in between them. Equals log base 10 of 6 to the x plus 1. This right here is my issue. But what can I do? This is the extra step, and you have to notice it. When I have log base 10 of 2 things multiplied, what can I do? Expand them by? You guys remember you can take addition and put them together as multiplication, but you always forget that you can take multiplication and expand it out as addition. This is the only extra step. Log base 10 of 2 plus log base 10 of 3 to the x. And now I'm back to every single step I had before. There is one extra step. That is it. Once I'm to this step and they're all expanded out, take your exponents, drop them in front. Distribute. You're back to the exact same steps as before. This is the one extra step right here. That's it. So now I'm going to go log base 10 of 2 plus x log base 10 of 3 equals x plus 1 log base 10 of 6. Then I do what? Distribute. We're at the same steps as before. Log base 10 of 2 plus x log base 10 of 3 equals x log base 10 of 6 plus 1 log base 10 of 6. Then what do? All your x's to one side. So I'm going to go x log base 10 of 3, and I'm going to subtract over negative x log base 10 of 6. And then I have log base 10 of 6 on the right, and I'm going to move that over because it doesn't have an x, minus log base 10 of 2. That's my next step. GCF. Is this hard? No. I don't know why so many people leave these questions blank, or they just do them poorly, or they multiply the 2's in right away or something. So you have to go through and practice the questions. If you don't, you won't remember the steps. Log base 10 of 3 minus log base 10 of 6. Is it a lot of work? Absolutely. I don't disagree with that statement, but I don't think it's hard. It's just a lot of steps. More practice, easier it becomes. Divide this over. Then what do? Put the logs together by product or quotient, and neither of them have numbers in front, so that's great. They have just some plus or minus ones. So I'm going to get x equals log base 10 of 6 over 2 over log base 10 of 3 over 6, which equals log base 10 of 3 over log base 10 of a half, which equals log a half